63. In lesson 63, we're going to be subtracting a fraction from a whole number that is greater than 1. So if I have a fraction that's 1/3 and I'm trying to subtract it from 1, then what I need to do is change that 1 into a fraction. How do I do that? First, I look and see what is the denominator. Oh, I left it on my... Well, that's what I'm using because I can't change it right now. So what would this 3, since it's a denominator, what do you think I'm going to write 1 as a fraction? What number would I use?
3/3.
3/3. Very good. So I want to keep it with the same denominator. So I'm going to rewrite it so that 1 whole is now written as a fraction as 3/3. And again, I got the 3 because I already had a denominator of 3, and I want to make sure my denominators match. They are the same.
I don't have a whiteboard.
Okay, you don't need one right now. So when you rewrite it, now you can see that you're subtracting 3 minus 1 to get 2 from my numerator, and 3 will always stay the same. The denominators don't change when you add and subtract fractions.
True.
Okay, imagine that we have 4 whole pies on a shelf, but somebody asked for half of one. Just one. We would have to cut one of the whole pies into 2 halves.
Why did they ask for
Before removing half a pie from the pan, we should have 4 pies, but we could call those pies 3 and 2 halves. Why? Because only one of them is split up into halves. So I have 1, 2, 3, and then I have a half, and I have another half. How many halves do I have? 2. So 2 out of 2, 2 halves is what I would say. All right, here's another example. Name the number of shaded circles as a whole number and as a mixed number. So first, what would the whole number be? How many circles do I have shaded? 3. Okay, so my whole number is 3, which is equal to, now looking at how it's broken up, how many whole circles do I have there? 2, and then the other one's broken up into 4 parts, but how many are shaded? 4 out of 4. Is 2 4/4 the same as 3 wholes? Yes, it's showing you right there. It is the exact same thing. It can just be broken up a little bit differently. Okay, make sure you're paying attention, please, and not talking. How many fourths represent 2 and 1/4? Okay, now think. How many fourths represent 2 and 1/4? Explain your thinking. Yes.
12, because a whole equals 4/4, and there's already 1/4, 1 whole, which is already cut up into 4s. So I added those up, which is 4, and then the whole is 4, so I added that up, 8, and then I added the other whole up, which is 12.
So we have 12/4, right? Very good explaining too. Thank you. We already have one that's broken up into fourths, he said. So if we had one like that and the other 2 are also done like that, then I have 3 circles that are each broken up into fourths, and he was doing in his head 3 times 4, which is 12. Does everybody understand how you get 12/4 pieces?
Yes. Yeah.
Okay, moving on. There were 5 pies on the shelf. We like pies whenever we have circles, if you haven't noticed yet. Or pizzas. A pizza pie. The server gave 1/3 of a pie to the customers. How many pies remained on the shelf?
Not enough.
So it's good sometimes to draw yourself a picture. So if I have, oh, these are real bad already. 1, 2, 3, 4, 5. Okay, I got 5 pies. The server gave 1/3 of a pie to a customer. How many pies remained on the shelf? So if we gave away 1/3 of a pie,
4 and 2/3.
what do I have left?
4 and 2/3.
What? How do you know?
2/3. Because I counted.
Because I just subtracted 1/3 away from it, right? Okay, if I did this with numbers instead of pictures, I would have 5 minus 1/3. Okay, how else could I write 5 minus 1/3? Yes.
4/4 minus 1/3.
I could do 4/4 minus. 4/4 minus a third.
Yeah.
What would I do?
4/4.
4 4/4 minus a third, but I'm still, what's wrong with this here? What's wrong with this? How many parts is it broken up into?
So that'd be 5.
But if I wanted to rewrite 5 as a fraction, how would that look? 3/3. Why am I having to write 3/3?
Because you're using thirds already.
Because I already was using thirds. Exactly, Lexi, and I want to keep my denominator the same. Very good. Okay, so now I can look at this and say, okay, well, if I do this, then I have 4 whole and then 2/3. So you have a couple different ways to do that. You've got your numbers down here, and then you have your visual. Visual sometimes is a little more helpful until you get to bigger numbers. Then it gets tricky. All right, a couple more examples. 4 minus 1/4. 4 minus a fourth. What would I have left over? Can you do that in your head? What would it be? 3 3/4. Very good. If I did 3 minus 3/4, I'm not taking away a whole, so it's not quite going to be 2 1/4. Very good. C, I'm taking away 4 minus 2 1/4.
2 3/4.
Is it 2 3/4?
2 1 3/4. 1 3/4.
Is it 1 3/4?
Yeah.
I want you guys to be sure.
No.
If I have 4
Yeah, 2
and I break them up into fourths,
2 3/4.
okay, I take away. All right, pretend all of these are shaded, okay? Now I'm taking away 2 wholes, gone, and a fourth. So what am I left with?
1 3/4.
Good, 1 3/4. I wanted to show you visually. Some of you were saying it correctly, but I think some of you were having a hard time because we were saying 2 3/4. But you got to remember, you're taking away 2 wholes already. So when you take away another fourth, you're down with 1 whole left. Okay, 2 minus 1/4. What does that leave me with? 1 3/4. Very good. 4 minus 1 1/2.
2 1/2.
2 1/2. Do we agree? You agree with yourself. That's good. Okay, and then F, 6 minus 1 2/3. We know it's going to be less than 5. 4 and what?
4 1/4.
What? Third. Very good. At noon, there were 3 pies on the shelf. Here, more pies.
Yay. My pie.
By 1 o'clock p.m., 1 3/4 of the pies had been served. Draw circles to represent the problem and find how much pie remains on the shelf. So for this one, I want to actually draw a picture. So if I have 3 pies here, 1 o'clock, 1 3/4 of the pies had been served. So what would I break each one of these pies up into?
4.
4 pieces. Okay? So one of these is gone, and 3/4 of another is gone, which means what do I have left? 1 1/4. Very good. Do y'all feel okay about that? Okay. Started on your assignment. It's going to start on page 438, lesson 63.
We have time.
Got plenty of time today. Hopefully nobody will have homework.